If I had this equation 3x minus 1 equals 4, and I wrote 3x equals 4 plus 1, and I said that the 1 had gone over the other side and changed sign, minus to plus, and that's mathematical, that when you move something to the other side it changes sign, then you might say that that's absolute rubbish and there's no such thing as moving something to the other side, and you can be completely right. There isn't any such thing in maths as moving something to the other side and then magically changing its sign. If we have an equation, we can do the same thing to both sides. You can do whatever you like, but you have to do the same thing to both sides in order to maintain the equality. So we could, for example, choose to add 1 to both sides, and then on this side the minus 1 plus 1 will cancel, and it looks as if the minus 1 has moved to the other side and changed to a plus, and it's a way of just thinking when you're manipulating algebra. It's not really what's going on. What's really going on is you've done the same thing to both sides, and that's the same with the separation of variables. I did a slightly dodgy step when I showed you how to do separation of variables, which I shouldn't really have done. So let's say we start with dy by dx equals 4xy plus 1. I said that what you do is you start by multiplying both sides by dx, and that's the dodgy step. You can't really do that. Dy by dx isn't a fraction. It's a symbol representing the limit of an infinite process, and to just treat it like it's a fraction is to have no respect for it whatsoever. But the net result is that we end up with, oops, I didn't do my dividing first. You have to divide through first by this term, and then you get 4x dx, and then you say, right, all my x's are with my dx and all my y's are with my dy, so that's okay, and now I can integrate. And also that's dodgy, just whacking an integral sign on and calling that integrating. That's not integrating. You can't, this symbol, that doesn't even mean anything without saying d something to say what you're integrating with respect to, but that was already there because it's all nonsense, isn't it? Let's do it properly. Okay, what I want to do is integrate both sides with respect to x. That is fine, I can do that. The integral of this side with respect to x equals the integral of this side with respect to x. Now the thing is, we've got the chain rule telling us that dy by dx is the equivalent of dx. It's not that those, of dy, sorry. It's not that those dx's cancel, it's that dy by dx is equivalent to dy. So that left-hand side is fine, but this right-hand side is no good. We can't integrate y minus 1 with respect to x. And we haven't got an integrating chain rule that we can use, so this is a problem. And because we know that this would cause a problem if we integrate both sides with respect to x, we start by dividing through by the y minus 1. So the first thing we do is divide through by y minus 1. And then we integrate both sides with respect to y, with respect to x. Perfectly legitimate mathematically. Then on the left hand side we use the chain rule to say that dy by dx is equivalent to dy. And we end up exactly where we would end up if we thought of it as the dx moving to the other side and then dividing and then whacking an integral sign on. So the net result when you get down to here is exactly the same, but this is actually, all of these moves here are perfectly legitimate, whereas the way that I showed you to do it is mathematically a bit dodgy. In general, we say that a differential equation is separable if it can be written in the following form. You've got your dy by dx there, you've got it being multiplied by a function of y, and equal to a different function of x. That's a separable differential equation. It might not look like that when you start, but it's possible to get it into that form. And the way to solve a separable differential equation is to integrate both sides with respect to x. Use the fact that dy by dx is equivalent to dy. And then integrate both sides. Now, the other thing I said I would mention is the thing about putting the plus c only on one side. Let's say I didn't. Let's say I integrate this and I get f of y. and I put plus c. And then I integrate this and I get g of x, some function of x, plus c. Now I haven't added anything. In adding the same plus c to both sides, I haven't actually added anything at all because they cancel. So this just gives me f of y equals g of x, and I haven't got a constant of integration. That's no good at all. Okay, so you might say, well, okay, how about you add a different one on the right hand side? Okay, sure, I can do that. I can add c on the left and d on the right, and that is the same as me having g or f of y equals g of x plus d minus c. And then I might say, well, this is just a number, can I just call that e? Don't see why not. So then I'd have f of y is g of x plus e, and if I'm just going to call it e, why don't I just call it c? Why don't I just add c to the right hand side? So hopefully that convinces you that there isn't a problem with only adding it to one of the two sides of the equation.